everyone. Today this is my project and I'm going to be investigating human reaction times. Okay? Perfect. So, reaction times are can be different by a margin or by a little bit between each person, okay? On this project, I'm going to be investigating two different individuals and see what their reaction times are looking like, okay? So each individual is going to get 15 attempts, right? Which is all going to be recorded. We're going to have 30 reaction time entries, sorry. Okay, so what I used for my project was a reaction time slip. We used Excel. We used some algebra that you put into Excel, okay? So the reaction time strip was all 1 millimeter apart, and we used the kinematics equation to calculate the corresponding distance for each time. Okay. I mixed that up. Sorry. The time for each corresponding distance. Okay. Now the algebraic manipulation was utilized and plugged into Excel to quickly and accurately determine the time for each distance. And then we recorded on the reaction strip as the image is shown, okay? I mean, it doesn't show here, but this is more of what the strip looked like, okay? Perfect. Okay. But now this is what I wanted to show you, which is distance versus reaction time graph, okay? But with known time increments, okay? This graph was generated to reflect the corresponding distance in meters using the kinematic equation that we showed previously in this slide. Okay? Perfect. Now I want to show you the distance for reaction time, but with known distance. With known equal distance increments and the kinematics equation that we saw in slide 3 to determine the corresponding time. This graph was generated to show you the relationship between distance and time. So you see how this graph has more of a curve going upward, and this one has more of a curve going downward. Look at the two graphs. Now you can tell how it is. Okay. So the equations that I used for this project was the kinematics equations that allowed time increments to be. We used the kinematics equation to give us the time so that we could put it on the reaction strip, okay? And we used the 9.8 gravity. A is going to be gravity. Okay, I won't explain the kinematics equation because we already took it. So equation 2, we got the mean. We got the mean of the reaction times using Excel, and the average. An average reaction time was determined using the table reflecting the reaction time of each trial. Okay, the average time was 389 milliseconds. That's what I got for both individuals. Okay, and the standard deviation for reaction times, again using Excel, we got the standard deviation and measurement of the dispersion form. The mean was determined from the reaction time for each individual trial. That was resulting in 73.30 milliseconds for each individual. Not for each individual. All right. So this is a graph that I got from Excel. Okay, I just wanted to show you it real quick. See how it's getting a slight curve going up because we know each time that we hit that the reaction times were. Yeah. Okay, this was my project off of Excel. I just wanted to show you it. So this shows how you see how the graph is going up, and the mean that we got and the minimum was a 279, the maximum was a 588. This was to show that all individuals were getting like close to the same amount of numbers. All right. So the question: the moon's gravity was the gravity on Moon is known for being 1.6249. Okay. Um, the reaction strip will basically be way slower, and therefore we would need to create like a smaller distance. We would need to create a smaller strip with smaller distance increments to allow to get an accurate measurement to be made. This makes sense like when we're plugging in numbers for times, even though the vertical distance for the reaction time per unit is much less than on Earth because gravity is decreasing slowly. Okay. All right. Now on Jupiter with gravitational acceleration of 25.94 milliseconds squared, the reaction time strip will fall almost 3 times faster than on Earth. Thus, the reaction strip would need to be spaced further for each individual. The reaction strip would need to be distanced further apart because every corresponding millisecond is like the vertical distance reaction time strip falls is greater than on Earth. So that means we just need to space it out more to get a better and accurate answer on the distance. Okay. And that was it. That's all I have for today. I just wanted to show you it was more of a one person reaction time than two, because I made each person hit 20 times to get their reaction time, and we did it only 35. The other person couldn't finish, so I'm sorry about that, but I hope you enjoyed. Thank you.